Good morning, guys. Mr. Middleton here. Today we are going to talk about simplifying radicals with fractions. So by the end of this lesson, you should be able to simplify radical expressions that include fractions. We'll talk about our division properties for radicals. We'll talk about simplifying radicals. We'll also talk about rationalizing the denominator. Okay, so all that in today's lesson. Let's just jump straight ahead. Okay, so our division property of radicals, we'll jump right into it. Basically tells us that we can rewrite a problem. Okay, if we're given a problem like radical A over B, here's a fraction, that'd be the same as saying radical A over radical B. Okay, and sometimes that'll help us out because we'll find a number that we really like in the denominator that'll help our problem be solved quicker. Sometimes having it as a fraction will help us out because we'll see that, hey, we can simplify it. Sometimes looking at it as a fraction makes it easier for us to see that. Okay. So let's jump into some examples. This first one, we have radical 9 over 25. Okay, notice right now that there's a fraction under the radical. But I see underneath, or in the denominator of my fraction, that I have 25. Okay, this is one of those times where it's going to be advantageous to us to separate it. Got radical 9 over radical 25. Okay. Now, it helped us to separate it because we have perfect squares. What's radical 25? It's 5. What's radical 9? It's 3. So radical 9 over radical 25 is just 3/5. This is our answer. Okay, and you calculator gurus, I don't want to see 0.6 or anything like that. Okay, that shows me that you probably just typed into a calculator. Okay, this is how we do it with our radical rules. Alright. Okay, number 2. Looking at it the same kind of way. I notice in my denominator I have radical 16. Okay, that's going to be, again, helpful for me to separate these. I have x to the 5th in my numerator. I have radical 16 in my denominator. Square root of 16, radical 16, that's 4. Okay. Here I have to take the square root of x to the 5th at radical x to the 5th. Okay, I have 2 pairs of x's and another x without a pair. Okay, so it stays underneath the radical. Okay. And in my final answer, I should always check to see, can I simplify this any further? And I can. Okay. X and 4 don't simplify. I can't do anything with this because x is inside and 4 is outside. Okay, our rule that, insides multiply insides, outsides multiply outsides, goes with division as well. Insides divide insides, outsides divide outsides. Okay. Okay, now, these are pretty basic examples. As we get more complex with more, possibilities of how you can do it, we'll run into some issues where our numbers just aren't as pretty. Okay, and so as we do that, the main rule that I want you guys to remember is that you cannot have a radical in the denominator of your final answer. You cannot have a radical in the denominator of your final answer. Okay, and when that happens, we'll show you how to rationalize the denominator. Okay, kind of introduce fancy one. All right, so let's look at this next problem. As we look at this, we have radical 75 over 12. In this case, I don't really see any really nice numbers. Okay, but I do see that 75 and 12 probably can be simplified. Okay, because 3 goes into both of them. So I'm going to simplify this. I'm going to keep it, well, let's see, 3 goes into both of these. I'm going to divide it by 3. And that gives me 25 and 4. Okay, radical 25, radical 4. Okay. Alright, square root of 25 is 5. Good. Square root of 4 is 2. Okay, so I got rid of all my radicals. 5 over 2 works out. Again, I don't want 2.5 as the answer. We're dealing with fractions. That way you know how to do it, and I know that you know how to do it, not just depending on the calculator. Okay. Looking at number 4, hopefully I gave myself enough space. But looking at number 4, I have 100x to the third over 18x to the ninth. Okay. Again, the toughest part is making sure that my denominator works out really nice. Okay. So I'm going to try to simplify this first. Okay. Because my denominator is not a perfect square as it is. I might as well, if I can simplify it, simplify it. If I run into a problem where my denominator is a perfect square, but I can simplify, I will probably prefer to take out the perfect square, factor the denominator without simplifying first. But we'll see why in just a little bit. Alright, so 118, what goes into both of those? Well, they're both even numbers, so I know that 2 goes into both of those. So I'm going to factor that out by 2, okay? Using my exponent rules, I'm going to divide these. Okay, my bigger number's down here, so I'm going to subtract 3 from there. Alright, and so when I do both of those, I have radical 50 in my numerator. 100 divided by 2 is 50. Take that down. 9x to the 6th. Okay, and that's in the radical as well. Alright, and so doing that, now I see that I do have perfect squares in my denominator. That helps me out, kind of simplifies the problem. I'm going to simplify it. I kind of didn't give myself space. I'm going to write it down here. Okay, radical 50 goes into 25 and 2. It's 5 and 5. So in my numerator I have 5 radical 2. In my denominator, square root of 9 is 3. Square root of x to the 6th is x cubed. Again, you should always be checking to make sure that you can't simplify anything else. Okay, so 5 and 3, they don't have any common factors. X cubed and 5 don't. 2 is inside the radical, can't do anything with that. Okay, and so that's our final answer. Okay, so can't have any radicals in the denominator, but we avoided those two problems by simplifying. Okay, but we won't always be able to avoid it. So let's look at number 5. Here, number 5, I'm looking at these numbers. See, I don't have a perfect square in the denominator, but I do see that they have a common factor of 2. So I'm going to simplify it. When I do that, I have radical 25 over radical 3. Okay, I can simplify that just a little bit further, and that gives me 5 over radical 3. This cannot be my final answer. It can't be my final answer because I have a radical in the denominator, and as I said, you cannot have a radical in the denominator of a fraction for your final answer. How do we get rid of it? Okay, so I'm going to introduce you to fancy 1. Okay, I have 5 radical 3. Like I said, you can't have radical in the denominator. Why? Because they say you can't. Okay, somebody who's started math, didn't like having radicals in the denominator. We can get rid of it. We can fix it. So that's what we'll do. Okay, and we'll do that by multiplying by fancy 1. We multiply by 1 because multiplying anything by 1 doesn't change the value of the number. Okay, right? But I call this fancy 1 because this fancy 1 will change how our problem looks. Okay, it'll change what our problem looks like, but still just 1. So, when we think about how can we get rid of this radical in the denominator, well, we can get rid of a radical by multiplying it by itself. Okay. And the reason that we can do that is any radical multiplied by itself is like 3 squared. It would become 9, which square root of 9 is 3. Okay, it gets rid of the square root. Okay. In our numerator, remember our rules: outsides by outsides, insides by insides. So 5 is outside, radical 3 is inside. We can put them together, but we can't like multiply them. Can't multiply them together. And so I'd like you to notice that this radical 3 over radical 3 is just a 1. This is what I will refer to as fancy 1. That's fancy 1. Again, it's fancy. It's all dressed up, but it's still just 1. And it helps us to get rid of our radical in the denominator. Because radical 3 times radical 3 is radical 9. Radical 9 is 3. Okay. And we can have this as our final answer. This is okay. This is okay. This is not okay to be our final answer because there's a radical in our denominator. Alright? Number 6, let's look at it. Can we simplify these two? The answer is no, because 6 is inside the radical and 10 is outside the radical. And our rule, as simply as I can put it, insides by insides, outsides by outsides. Okay? This is outside, this is inside, they don't mix. So let's simplify it. Or actually, we can't simplify it. So this would really be our final answer because 6 doesn't break down to anything but 3 and 2, but we can't leave it where 6 is in our denominator. So we have to rationalize the denominator. And again, we'll use fancy 1. In this case, I'm going to just multiply by radical 6. Radical 6, radical 6. Okay, when I do that, in my numerator I'll have 10 radical 6. Following my multiplication rules. In my denominator, I'll have 6. So radical 6 times radical 6 is radical 36. That breaks down to 6 and 6. Okay, up here goes out, it's 6. Now I look at this problem and I say, can I simplify this? In this case, I can because 10 and 6 are both outside. They're both even numbers, so they share 2 as a factor. So I'll have my final answer. I'm going to write it down here. 5 radical 6, that doesn't change, over 3. And that's my final answer for that problem. Okay. Number 7. Alright, so same base, dividing exponents. So I do that, I'll have radical 1, I'm going to subtract 4 from here, over a to the 5th. Okay. I can try to simplify this. If I do that, I'll get 1 over a squared a. Alright. Now, this cannot be my final answer, even though I don't have all a radical in the bottom. I do have a radical in the denominator. So, again, I'm going to have to use fancy 1. So I have 1 over a squared radical a. And I'm going to multiply this by radical a. Okay, I don't have to multiply it by the whole thing, just radical a because that's the thing that's inside the radical. And so what that gives me is radical a in the numerator, 1 times radical a. And in the denominator I have a squared, and I'm multiplying these two. So radical a is a times a squared is a to the 3rd. I can't simplify this any further because a is inside the radical and a cubed is outside the radical. And so this is my final answer. Again, notice that fancy 1 now looks like this. Okay, fancy 1 isn't always something, it's just the radical over itself. Okay. Last problem, if you want to really challenge yourself, try this on your own. If you want to follow me, go ahead and do that as well. Okay, so I see these x's, I'm going to subtract 3 there. 12 and 5 don't simplify anymore, so I'll have radical 12x to the 8th over radical 5. Okay, now I can simplify this if I wanted to. What I'm going to do is I'm just going to multiply by radical 5 first. And you can do it in any order that you want. Some people will prefer to get rid of the this and make it a smaller number as soon as possible. Some people would prefer to get rid of the radical in the denominator as soon as possible. I'm one of those people. Okay, so I'm going to multiply this by radical 5 over radical 5. write that answer out here. When I do that, I will have radical 60 x to the 8th over 5. Okay. Now this isn't my final answer. Even though I don't have a radical in the denominator, I still will need to simplify my numerator as much as possible. And so when I do that, 60 breaks down into 12 and 5, 4 and 3, 2 and 2. So, and then x to the 8th, I have 4 pairs of x's. So I have a pair of 2's, 4 pairs of x's, and then not out was 3 and 5, so I have 15 over 5. Nice. Alright, and so that's my answer. So looking here, you have seen how to rewrite problems. You have seen how to simplify using the perfect square roots in the denominator. You've seen that you can simplify fractions like we had before and continue to take the perfect square. And then you've used fancy one to rationalize the denominator. Okay. We will look at some more questions like this tomorrow and kind of make sure we're coming into our own with simplifying these radicals. All right, see ya.